Let's take a look at reactions of fatty acids. Fatty acids, as you know, are the building blocks of fats. So if I ask you, can you hydrolyze a fatty acid, we'll say this: fatty acids, none of these can be hydrolyzed. You know what hydrolysis is. Hydrolysis is breaking apart. You can't break apart these fatty acids. They're building blocks. They're the smallest piece of a fat. So these cannot be hydrolyzed. What kind of reaction then can they do? There's only one reaction we'll see right now in this video of fatty acids. There's a second one we'll see in the next video. The first one we'll see right now is hydrogenation. You already know what hydrogenation is, right? Hydrogenation, I'll put it right here. Hydrogenation is this: carbon-carbon double bond turning into a carbon-carbon single bond. That's hydrogenation right there. We've seen that before. We said an alkene will turn into an alkane by hydrogenation. In the context of fats and biochemistry, we have not been calling this an alkene. We've been calling it an unsaturated fat. We've been calling this a saturated fat, but the reaction's the same. You've already learned this. We don't have anything new to say. We'll show a few examples to refresh you on it, but there's nothing new that's happening. Take a look at this fatty acid right here, then we'll do that example first. If we want to hydrogenate it, we would react it with H2. You know you need a catalyst, maybe it'll be nickel. That reaction type is hydrogenation. Why can it do that? Because it has two carbon-carbon double bonds. Every carbon-carbon double bond needs a molecule of H2. So if I have one molecule of fatty acid, I need 2 molecules of hydrogen. If I have a mole of this, I need 2 moles of this. We don't need to worry about that exact language, but I do want you to see that if I have more of these double bonds, I need more hydrogen. What will happen? Same thing we already know. The double bond will turn into a single bond. And so let's look at that. How will that look? Nothing else will change. That's still there. So I'm going to number these carbons so that we don't get mixed up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And here we have those, the same molecule. But notice that on carbon 10 and 9, that double bond will go away. So this was carbon 18, 17, 16, 15, 14, 13, 12, 11. And now, right here, that will have an H, and so will carbon 9. Eight, 7, 6, 5, 4, 3, 2, 1. Carbon 7 and carbon 6 also lost their hydrogens. I'm not drawing them in here. We don't need to draw in the carbons when they're not on a double bond. In fact, we didn't even draw them in here. We don't need to draw in the hydrogens. I might have said don't draw carbons. We don't need to draw the hydrogens, but we can see that we no longer have a double bond. Double bond turned into single bond. And notice that bend, or that shape right there, is gone because we don't have a double bond anymore. This was a poly unsaturated. In fact, it was 18,2, and it turned into a saturated 18,0. The number of carbons doesn't change. All we're doing is turning the double bond into a single bond. Now it's gone. We converted a polyunsaturated into a saturated just by reacting with hydrogen. You should do a bunch more examples on your own to see this. We'll do one more together right now. because I want to show you what happens if you try to add hydrogen, react with hydrogen for a saturated fatty acid. This one right here is saturated, right? There are no double bonds. There are no carbon-carbon double bonds. So what will happen when you try to hydrogenate it? That's the name of this reaction, hydrogenation, hydrogenation. We've seen that before. What happens when you try to hydrogenate a saturated fatty acid that has no carbon-carbon double bonds? What will happen? Nothing. It can't react. No reaction because there are no carbon-carbon double bonds. If you see carbon-carbon double bonds, it can hydrogenate. Otherwise, it cannot. I see a double bond here. This will react. This can get hydrogenated. This one can get hydrogenated. This one cannot. Don't be fooled by this bond. That's not a carbon-carbon double bond. It's oxygen. That's not involved. Only carbon-carbon. Also be sure to notice, I'll look back up at this one, be sure to notice we're not chopping the molecule up. This is not hydrolysis. All we're doing is taking that same structure and converting it from carbon-carbon double bond to carbon-carbon single bond. So practice that. There's a whole bunch more examples on this page. Practice with writing the structure of what you get when you try to hydrogenate fatty acids. The second reaction that fatty acids can do is condensation to make a fat. We've learned that they're the building blocks of fats, so when they combine with other things, they'll make a fat, and we'll see that in the next video.